Assalamualaikum. So we continue our lecture, part 3 in chapter 6. Okay, so we will discuss about the ideal gas equation. So ideal gas law is the combination of the three simple gas law that we have discussed previously. So after combine and setting all the three laws, we get the equation that we call it as a ideal gas equation. This is the ideal gas equation. So we have PV equals to nRT. So P is pressure, V is volume, N is mole, number of mole. R is gas constant, and T is temperature. Okay. Okay, this table shows the values of universal gas constant R. So the values of the gas constant depends on the unit you use. Okay, either we use the 0.082057 and the unit is liter atm per Kelvin per mole, or we use 8.314472 liter kilopascal per Kelvin per mole. Look at the example. Okay, so how many moles of gas does it take to occupy 120 liter at a pressure of 2.3 atmosphere and a temperature of 340 Kelvin? Okay, so you have to find the number of moles of gas based on the information given. You have 120 liter, so volume, and then you have pressure at 2.3 atmosphere, and also you have temperature at 340 Kelvin. So we use the ideal gas equation, PV equals to nRT. So P we have 2.3 atm, and then volume we have 120 liter equals to N times R. So R mana yang kita nak gunakan? Kita guna the first one, 0.082057 liter atm per Kelvin mole. Darabkan dengan T, 34 Kelvin. Okay, kenapa kita gunakan 0.082057 liter atm per mole Kelvin? Sebab dekat sini ada atm. So dekat sini pun, dekat sini ada atm, dekat sini ada atm, so kita boleh cancelkan, ya. So kita akan dapat tu 76 equals to N times 27.89. Okay, so N equals to 9.89 moles. Alright, okay, boleh ya, for ideal gas equation calculation. Okay, next we look at the standard temperature and pressure. So STP in chemistry is abbreviation for standard temperature and pressure. STP most commonly is used when performing calculation on gases such as gas density. So STP refer to standard temperature and pressure. So remember, at STP condition, the temperature is 0 degrees Celsius or 273.15 Kelvin, and the standard pressure is 1 atm, okay, equals to 76 equals to 7660 millimeter of mercury. Okay, so at STP, 1 mole of any ideal gas has volume of 22.42 liter. And look at the example. Okay, what is the volume in liters occupied by 49.8 gram of HCl at STP? Okay, so kat sini dia dah bagi mass of HCl and dia dah bagi tahu at STP condition. Okay, so kita tahu STP condition, kita ada pressure equals to 1 atm and temperature 0 degrees Celsius or 273.15 Kelvin. Okay, so kita dah ada nilai pressure and temperature. So apa kita nak buat dengan nilai mass of HCl? So from mass we can calculate number of mole and equals to mass over molar mass. So small m is referred to mass and capital M is a molar mass. So you have to calculate the molar mass of HCl. So molar mass of the HCl, 36.45 gram. Okay, so kita masukkan dalam formula. So N equals to 49.8 gram over 36.45 gram. So you will get 1.37. Okay, so 1 mole of HCl, so we get 1.37 mole. Okay, so dah dapat nilai N, so kita ada P, kita ada T, so we can calculate the volume. Okay, so kita gunakan PV equals to nRT, so V equals to nRT over V. So N we have 1.37 mole times with R constant. Okay, so gas constant we gunakan 0.0821 mole. Okay, sorry, it's not mole, liter atm per Kelvin mole. Okay, harapkan dengan temperature. Temperature is 0 degrees C or 273.15 Kelvin over P. P is 1 atm. Okay, this one tukarkan P. Alright, so you calculate, you can cancel the unit. Okay, so you will get the answer is 30.7 liter. Right? Okay. Next, we look at the density and molar mass. So the density of a particle gas depends on its molar mass. This shows the equation for the density. So M equals to D RT over P. So M is a molar mass D is a density, R is gas constant, T temperature, and P is pressure. Okay, so the density of gas is directly proportional to molar mass. T directly proportional to molar mass. So gas with small molar mass will have lower density. Okay, and vice versa. So this is the example again. 2.10 liter vessel contain 4.65 gram of gas at 1 atm and 27 degrees Celsius. What is the molar mass of the gas? So here kita dah ada volume, kita dah ada mass, kita dah ada pressure, and also kita dah ada temperature. So you have to calculate molar mass. Apa yang you perlu buat ialah come up with the equation with the formula. So kita ada formula kita ialah molar mass equals to density RT over P. Okay, so P kita dah ada, R kita dah ada, also T juga kita dah ada. So how to calculate the density? First, you have to calculate the density. Density equals to mass over volume. So mass is 4.65 gram over 2.10 liter. So you will get 2.21 gram per liter. Okay, so this one is a density. Kemudian dapat kita masukkan dalam formula 2.21 gram per liter times 0.0821 liter atm per Kelvin per mole times 27 plus 273 equals to 3.15 Kelvin. Okay, so kita masukkan dalam formula 300.15 Kelvin. Okay, so over pressure. Pressure is 1 atm. Okay, so K boleh cancel dengan K, ATM boleh cancel dengan ATM, liter boleh cancel dengan liter. So you will get the 54.5 gram per mole. Alright. Okay, next we look at the gas stoichiometry. So stoichiometry calculation involving gases allow us to convert between mass, number of mole, and most importantly is volume of gases. So kita akan gunakan gas stoichiometry ini untuk relationship between amount and volume, to solve the problem. Okay, this one, this image show how to calculate the mass of product using the gas stoichiometry. We start with amount of reactant, either grams of volume, and then from the mass of the reactant, we calculate the moles of reactant involved, and then from moles of reactant, we can calculate the moles of product, and from moles of product, we can calculate the amounts of product. Look at the example. Okay, example, what is the volume of carbon dioxide produced at 37 degrees Celsius and 1 atm when 5.06 gram of glucose are used up in the reaction? So you have to calculate the volume of carbon dioxide. So we have temperature here 37 degrees Celsius and pressure is 1 atm. So based on the chemical equations given, so make sure the chemical equation are balanced. Okay, so kalau tak balance, you have to balance first. Okay, make sure to balance. Okay, so this equation shows that 1 mole of glucose react with 6 mole of oxygen, produce 6 mole of carbon dioxide and 6 mole of water. Okay, so nak tentukan mass of or volume of carbon dioxide, kita gunakan step yang kita dah discuss sebelum ni. Okay, so daripada mass of reactant, so you have to calculate the mole of reactant. So from mole of reactant, kita convert to mole of product, and from mole of product we can calculate the volume of product. Okay, so the first, don't forget to convert the temperature to Kelvin unit. Okay, so 37 plus 273.15 equals to 310.15 Kelvin. Okay, so from mass of glucose, we can get the number of mole of glucose. So mass over molar mass, 5.60 over 180 gram of glucose. Okay, so from number of mole of glucose, we can find the mole of carbon dioxide. So 1 mole of glucose produce 6 mole of carbon dioxide. That's why you dapat 6 mole of carbon dioxide over 1 mole of glucose. Dan bila you bahagi dan darab, so you will get 0.187 mole of carbon dioxide. So bila dah dapat N of carbon dioxide, kita masukkan dalam formula ideal gas equation, V equals to nRT over P. So V is 0.187 mole carbon dioxide times with 0.0821 liter atm per mole Kelvin times with temperature is 310.15 Kelvin over 1 atm. So we can cancel the unit. Okay, mole with mole, Kelvin with Kelvin. So bila kita darabkan, kita akan dapat 4.76 liter. Okay. Okay, next example. What volume of hydrogen molecule at 765 torr and 2 to 5 degrees Celsius is needed to reduce 35.5 gram of copper to oxide to form pure copper and water. So again, you have to write the balanced chemical equation. So copper to oxide, 1 mole of copper to oxide react with 1 mole of hydrogen, produce 1 mole copper plus 1 mole water. So kita kena cari, first step kita kena cari number of mole of reactant kita. So 35.5 gram of copper to oxide, divide with molar mass of copper to oxide, 79.55 gram. Okay, dan bila dapat nilai N, kita buat perkadaran. 1 mole of copper to oxide react with 1 mole of hydrogen. Okay, that's why buat 1 over 1. So you will get the N, number of mole of hydrogen is 0.446. Okay, so bila dah dapat, masukkan dalam formula PV equals to nRT. Okay, so PV equals to nRT, N equals to, nak cari apa? Volume. So V equals to nRT over P. So N is 0.446 times with R, 0.021 atm liter per mole Kelvin times with 468 Kelvin over 1.01 atm. So mana nak dapat 468 698 Kelvin. So kat sini you ada 225 degrees Celsius. So 225 plus 27, 3.1. So you will get the Kelvin unit. Okay. Macam mana, ada pelajar tanya macam mana 765 torr daripada torr boleh jadi 1 ATM. Remember, 1 ATM equals to 760 torr. Okay, so let's say if you have 765 torr, so you darab lah 765 torr times 1 ATM divide 7.60 torr. So you akan dapat 1.01. Okay, so this one untuk P, lepas tu convert. So you masuk dalam formula, so you will get the answer is 18.1 liter. Alright, okay. Finish for part 4 in chapter 6. Thank you.